everyone, I am Prerna Manleshmi. We are currently in a third year pursuing electronics and telecommunication engineering. During the period of an internship, we made a project in IoT called Home Automation System.
मी ईर्षा तांबोळी. वी आर द स्टुडंट ऑफ शिवनगर विद्याप्रसारक मंडळ कॉलेज ऑफ इंजिनिअरिंग माळेगाव.
Hello everyone, my name is Arbaz Sheikh. Today we are going to give a presentation about our project Home Automation System. So let's begin.
This is the scope of the project and these are the contents of it. During my internship, I have studied the following topics which included C programming, C++ programming, IoT and embedded systems. In C programming, I have studied keywords, basic data types, operators, conditional constructs and looping concepts, arrays, pointer functions, storage classes and header files. In C++ programming, I have studied the basic OOP concepts and I have studied the introduction to IoT along with embedded systems and also about peripherals. These are the peripherals required for the project. Now, what is peripheral? Peripheral is an internal or external device that connects directly to the computer. These were required in the project. I have used LDR sensor, temperature system and serial tank. Now, let's see what is IoT. IoT means Internet of Things. Simply describes physical objects that contain embedded technology. This is the architecture of IoT. Now, what is embedded system? An embedded system is a combination of computer hardware and software designed for a specific function. This is the architecture of embedded system. These are the project requirements. Controlling garden lights on basis of sunlight intensity, temperature system control and water tank control. These are the components required for the project. In hardware, we have used Arduino Uno, ETH-W5500, PSF8574 temperature sensor, LCD, LDR sensor and LED. In software, I have used Arduino IDE, which is used for coding, Pixim Lab used for simulation, Null Model emulator to configure ports of serial remote tank, and Blink IoT app. It is a mobile app which controls the operations. Now, let us know briefly about all the requirements that are used in this project. Firstly, Arduino Uno. Arduino Uno is an open source microcontroller board based on Atmega 328P microcontroller. This is how it looks. ETH-W5500 is an Ethernet. It is a hardwired TCP/IP embedded Ethernet controller that provides internet connection to embedded system. Here is the Ethernet server. PCF8574. It is a silicon CMOS circuit. It is a 8-bit input-output expander. Temperature sensor. It is an electronic device that measures temperature. LCD. Liquid crystal display controller, which displays alphanumeric and symbols. LDR sensor. It is a light-dependent resistor. And here is the picture of it. Now, let us briefly look into the implementation of the project. These are the output screenshot. This is the first step when we load the hex file. Here is the LED on-off pictures. When LDR is high, LED is on, and when LDR is low, LED is off. Here comes the cooler pictures when cooler is on and off. These are the heater pictures where heater is on and off. This is inlet valley when it is on, inlet valve when it is off, outlet valve when it is on, outlet valve when it is off. These are the mobile screenshots from Blink IoT app. This is the notification of heater temperature. This is when heater automatically turn off when temperature rises above 35. This is notification of water level. This is water tank. This is when water tank is full, inlet valve will automatically turn off. Water volume level. Here comes the last part of this PPT, that is conclusion. Here in this project we are using the necessary requirements and integrating those, and we are building a IoT home automation project which is controlled by Blink IoT mobile application.
Thank the EMERTEX technology for providing us the internship and giving us all the guidance throughout the period of internship.
I will explain you the code for this home automation project. First of all, we are including all the required header files and libraries into it. Then we are writing our authentication code, which is of Blink Cloud. Then we are initializing the variables, declaring it, and we are including the libraries that is required. Then we will mention different functions and their definitions into it. So this cooler vpin function defines, it gives us the control to control the cooler by clicking it on and off using our mobile app Blink IoT, and the LCD will display the cooler is on and cooler is off. Similarly, when it comes to heater vpin, this will take the input and then it will also display when the heater is on, it will show on, and then when heater is off, it will show off on the LCD screen. The inlet vpin will display the inlet flow of water tank. So it will again enable the inlet and it will show that the cursor on the LCD screen whether the flow is on or off, and it will take the parameters, it will read the values from the Blink app. Similarly, for output pin, it will again show whether the flow is on or off on the LCD screen, and these methods are called enable outlet and disable outlet. Update temperature reading function will be helpful for us to give the values to IoT app. So basically the app will show the display of the temperature as the temperature is moving. Even the water value will be displayed on the mobile app on the different tab. When it comes to handling the temperature, this will check if the temperature is greater than 35 degrees, then the heater will turn off and then it will print as the heater is turned off, and similarly a notification window will appear on the mobile IoT app where it displays that the heater will be off because the temperature is exceeding 35 degrees Celsius. When it comes to the function of handle tank, this will mention that if the tank volume is less than 2000 and the inlet valve is closed, at that moment it will turn on the inlet valve and it will show that the flow is on, and the notification will be printed on the mobile app that water level is less than 2000, so the flow will be on. Similarly, if there is the volume of 3000 and if the inlet valve is open, at that moment it will disable the valve. That means the flow will be stopped and it will be mentioned on the LCD that the flow is off simultaneously. On the notification window of the app, it will be mentioned that water level is full, so it is stopped. In the setup, we will always initialize, will always declare the init methods, and in the loop, we'll always call the method that is already declared. In ldr.cpp, in this file, we are declaring the brightness control method, which means this method will declare that the blinking of LED with the help of LDR. In ldr.h, it is the header file where we have declared the macros LDR sensor and we have given it as a value, and we have also declared the methods. In main.h, here also we have declared all the macros that we are using in the program. Serial_tank.cpp will be declaring all the methods into it. In this volume method, it will declare the volume, how much volume is there in the tank and not. And the different methods like enable inlet will show that the inlet valve is enabled or not disabled, and various methods are declared over here. In serial tank.h, it is the header file that will mention all the macros in it, and the method names are declared over here. Temperature system.cpp will give us about the method's name, that cooler control. That means it will give digital write cooler dot control, which means that the values will be read by the system when the machine is on and off, and it will be passed and declared in the LCD. Similarly, when it comes to temperature, this will convert the temperature into degree Celsius. This method will be helpful to converting the temperature into degree Celsius, and it will declare all the methods that is required for the temperature system. And temperature.system.h, this is the header file where we are already declaring the method names and we are declaring all the macros. In this way, we'll be able to code our system, and once our code is ready, we'll compile it and we will upload the compiled code in the Arduino of PixSimLab. Once the compilation is done, the hex file is ready. Here the compilation is done and our code does not have any error, so we can upload it on the PixSimLab. Now let's look at the simulation part. So this home automation project consists of blinking of LED with the help of LDR. When we lower down the resistance, the light turns off, and when we increase the resistance, the light will turn on. Remaining part can be controlled by our mobile application. Here I have kept on the Blink app, where we can see the option of cooler. When we click on, the cooler starts to on, and over on the screen we'll see the cooler is on. When we click on the option off, the cooler will stop and it shows that the cooler turns off. When we click on the heater on, the temperature on the screen will increase, and when it turns above 35 degrees Celsius, automatically the heater turns off, and here we get a pop-up message that temperature is about 35 degrees Celsius, turning off the heater. If we again turn it on, it will increase the temperature, but automatically again it will turn it off. And when we turn on the cooler, the temperature decreases, the fan also turns on, and here on the screen we'll also get the temperature is decreasing. Similarly, if we turn it off, it turns off. When we go to the second tab, which indicates the water level, we can see it with the help of the serial monitor, where we'll see this tank over here. So let's look at the tank. So this is the tank. If we keep the inlet valve on, the tank is filled. Once the tank gets filled, automatically the flow is stopped. When we turn on the outlet valve, the tank is decreasing. Here on the screen it shows outlet is on, and once it decreases below 2000 liters, the inlet valve will get on. See here, the inlet is on. Again, when we stop the outlet on the screen, outlet is off. The inlet is full, and once it completes 3000 liters, automatically inlet will be off. Now the inlet is automatically off. We can turn on the outlet to check the water is decreasing. Here on the screen also it is decreasing, and on the tab 1 we can see a notification. The notification shows that the water level is less than 2000 liters, so water inflow is enabled, and if the water level is full, the water inflow is disabled. In this way, we are able to control the water level over here. So basically, in this internship, I have completed a project that is based on IoT home automation, for which we have just now seen the simulation. So basically what this project does is, this project we are controlling from a Blink IoT app from our mobile phones, where we look that when we turn on the heater will start, it will show on the LCD screen also. So heater turn off mechanism is controlled by this app. Then cooler turn on mechanism is controlled by this app. Then LED blinking using LDR is also controlled by this app. Then temperature sensor is also controlled by the app, and the temperature is visible on the mobile screen. And water tank outflow and inflow of water is also controlled in this project using Blink IoT app, and the notification is sent. So basically we are able to send the notifications and the temperature changes and water level changes on the mobile phone on the app, and we are able to control it from the mobile, and we can see that on the laptop screen on this PixSim lab simulator. Though this